Bagsak na naman ako. Kailangan ko na talagang mag-aral.
What is deflection of beam? In the context of strength of materials, deflection of a beam refers to the displacement of a beam from its original unloaded position when it is subjected to external loads. This deflection occurs due to bending moments and shear forces acting on the beam. Deflection is an important consideration in structural because excessive deflection can lead to structural failure, impair functionality, or cause discomfort in service. The amount of deflection depends on factors such as the beam's material properties, its moment of inertia, the type and magnitude of the load applied, and the beam support conditions. Now, there are 5 types of beam deflection based on the nature of the loading and the resulting deformation. First is the transverse deflection. This is the most common type and occurs perpendicular to the beam's length when loads are applied vertically. It can be further divided into uniformly distributed load, which is a constant load spread evenly across the beam, and the point load or the concentrated load applied at a specific point along the beam. Second is lateral deflection. This occurs when lateral loads or horizontal forces act on a beam, causing it to deflect sideways. This is particularly relevant for beams in structures subjected to wind or seismic forces. Next is the axial deflection. While not bending deflection, it occurs when a beam is subjected to axial loads, causing it to stretch or compress along its length. The fourth one is rotational deflection, which refers to the rotation of beams, ends, or supports due to applied moments, which can also lead to a change in the angle of the beam. And lastly, vibrational deflection. In dynamic scenarios, beams may experience deflection due to vibrations, which can be significant in structures subjected to cyclic loads. As I mentioned some of it before, beam deflection can be caused by the applied loads, support conditions, material properties, beam geometry, length of the beam, change in temperature, and dynamic loads. When considering beam deflection, there are several additional factors that are important to understand. Euler-Bernoulli beam theory and superposition principle are some of the various formulas that exist to calculate deflection based on the loading conditions. Different end conditions significantly affect deflection behavior and magnitudes. And in addition to bending deflection, beams can also experience shear deflection, particularly in short beams or those subjected to large shear forces. Total deflection is often the sum of bending and shear deflection.
Meron pa palang isa. Yung deflection methods, double integration, Macaulay. Tingnan nga natin sa YouTube ito.
So our example, we should calculate the value of EI theta at the right support of the overhanging beam. So first, dito natin makikita ang ating point of moment sa kalahati nito. Ayan. Pero, ang condition, kapag meron tayong distributed load na hindi pasok sa point of moment, need natin to i-extend. So ang mangyayari dito niyan, ang ating distributed load ay may extend. This will be 100 pounds per feet. And after nyan, din natin lagyan sa ilalim. Okay? Buray lang natin sa dito, lipat natin para magkasya. Wait lang yan. So maglalagay naman tayo sa ilalim ng another 100 pounds per feet. This will be another pound per feet. Yan. So 5 feet. Yan, 3 feet. So bakit nga ba natin ginawa to? Pero kapag ano naman, kapag ang distributed load natin ay nasa point of moment, hindi na natin siya need i-extend. So, lagi natin tandaan, kapag wala sa point of moment ang ating distributed load, need natin ito extend hanggang sa point of moment natin. Okay? So next, we will find or we will determine the value of reaction at A and reaction at B. So dito ang reaction at A, ito ang natin kulay. This will be the reaction at A. And reaction at B. Ay, pero bago yan, i-determine muna natin saan natin ilalagay ang X para hindi na tayo mahirapan. So ito ang point of moment natin. Dito tayo maghahati. Laging tandaan, lagi tayong maghahati sa kalahati ng kung sa segment ng BC. Okay? Yan. Dito tayo maglalagay ng X. Yan. This will be our X. And next will be our X minus 5. X and X minus 5. And then we will add 5 plus 5. This will be X minus 10. And next natin is we will determine our reaction at A and our reaction at B. This will be RA and this will be RB. So yan. First, let's look at our reaction at A. So moment MA is equals to 0, positive, clockwise. So RA, the equivalent. RA papunta sa B will be 5 plus 5 will be 10. And 10 siya. And then 100 feet or 100 pounds pala, 100 pounds per feet will be multiplied by 5. It will become 500. So ayan. Ito, wait. 100 multiplied by 5 will be 500. Okay? So, ano ang natin? So, dahil counterclockwise siya, it should be negative. Kaya, negative 500 pound per feet and i-multiply natin by 7.5. So, ito. Bakit naging 7.5? So, ang kalahati ng ito yan. Kasi ganito siya ikot yan. Ganyan siya. Papuntang B, counterclockwise. Sa kalahati ng 5 feet. Kaya 5 divided by 2 will be 2.5. Tapos, itong distance ito, another 5, ipa-plus natin. So, 5 multiplied by 2.5 and 2.5 is equals to 7.5. Okay? Ano natin yan? 7.5. Yan. Tapos, 240 ito clockwise siya, kaya positive siya. 240 found will be multiplied by 3 feet. Yan. Is equals to 7. Solve na natin. RA multiplied by 10 minus 500 multiplied by 7.5 plus 240 multiplied by 3. So if solved is equals to 303. So our RA is 303. RA is 303. 303 pounds. Next, solve natin ang ating RB. So moment of MA is equals to 0, positive clockwise. Yan. So RB, so 240. So 240 pounds. So hanggang ano siya, no? Hanggang moment ng A. So 240 is 3 feet plus 5 plus 5 is equals to 13. Okay? Is equals to 13 multiplied by 13. And then wait, tama. Ito, ang RB natin is pa-counterclockwise siya. Yan, yung ikot niya is counterclockwise. Pag ganyan, puntang A. Kaya negative. Negative RB multiplied by 10 plus 100 multiplied by 2.5. Yan. 2.5 is equals to 0. So 240 multiplied by 13 minus RB minus RB, which is 10, plus 100 multiplied by 2.5 will be 337. Our RB is 337. So this will be pounds and pounds. So dahil nakuha na natin ang moment natin, pwede na tayo mag-proceed sa double integration. Okay? So, next, we will solve for the moment at segment CD pala muna. So, ang mangyayari niyan is, yan. Kapag mag-solve tayo for moment CD, segment CD will be summation. So, summation of moment is equals to 0. Summation of moment is equals to 0. And the next. So, our moment is RA, which is 303 pound. It will be multiplied by X, and then minus 100, which is X minus 5. X minus 5. At ito ay ma-divide by 2. Kaya X minus 5 divided by 2. And dahil meron tayo nga, yung ginawa natin, ang in-extend natin kanina ng yung distributed load natin, dyan gagawin natin sa ilalim. Maglalagay tayo ng plus 100, yan, multiplied by X minus 5, ulit, X minus 5 divided by 2. Okay. And we will add another, which is our RB, which is the 337. It will be positive kasi, ano siya? Clockwise siya. Or ano siya? Paakit siya. Plus 337. And this will be the X minus 10. So, ang mangyayari is 2 divided by 100, magiging 50. 2 divided by 100, magiging 50. Maalis to, magiging squared na siya dito. Okay? So, ganito siya yan. 303x minus 50 x minus 5 squared plus 50 x minus 5 squared plus 337 multiplied by x minus 10. Yan. So, yan ang moment natin. So, ang next, after natin i-moment, next natin gagawin natin ang ating working equation, which is our double integration. So, paano natin sulat ang working equation natin? So, ito, working equation, ang next. Which is ELY is equals to M. Yan. So, ELY, 303x minus 50 x minus 5 squared plus 50 x minus 5 squared plus 337 multiplied by x minus 10. Ito pa. Ito pala, hindi parenthesis. Tatarin ito siya. X minus 10. And next is EIY. So 303, ang mangyayari is x squared divided by 2 minus 50 x minus 5, which will be n plus 1. So laging yan, n plus 1 divided by n. Okay? So magdadagdag tayo lagi ng plus 1. So kaya naging 3 to. n divided by natin by 3. Plus 50, ganun din ulit, multiplied by x minus 5, n plus 1, which will be 3, the power of 3, divided by 3, and plus 337 multiplied by x minus 10. So n plus 1 ulit, which will be x to the power of 2 divided by 2. So, ang mangyari next is 303 divided by 2. So, 303 divided by 2. 303 divided by 2 will be 151.5. 151.5 x squared minus 3 divided by 50. 50 divided by 3 is 16.667 multiplied by x minus 5. 3 plus 16.667, so 50 divided by 3 is 16.667 multiplied by x minus 5 raised to the power of 3 plus 337 divided by 2 will be 168.5. 168.5 divided by x minus 10 raised to the power of 2. Okay, next, our second integral naman. So our second integral is ELY 151.5, which is x multiply ulit by 2 ay n plus 1 ulit, so magiging 3 at i-divide natin by 3, copy lang ulit 667 multiply by x minus 5 raised to the power of 3, pero plus 1, n plus 1 will be 4, and i-divide natin by 4 ulit, plus copy 16.667, ganun ulit, x minus 5 multiply by x minus 5, which is n plus 1, 3 plus 1 divided by 4, copy 168.5 multiply by x minus 10 raised to the power of 3, n plus 1 divided by 3. Lang talaga. 3. So, yan natin. ELY 151.5 divided by 3. 151.5 divided by 3 is 50.5. 50.5 mali natin. Multiplied by x cubed minus 16.667 divided by 4. 667 divided by 4 is 4.167 x minus 5 is to the power of 4, copy, so same lang sila, 4.167 multiplied by x minus 5 is to the power of 4 plus 168.5 divided by 3. 168.5 divided by 3 will be 56.167. 56.167 multiplied by x minus 10 raised to the power of 2. Okay, so yun na ang ating. Hindi, may nalimutan pala ako sa sa first integral natin. Dapat sa first integral natin magdadagdag tayo ng C1. Yan. So sa second integral, so 6.167 x minus 10 is to the power of 3. So C1 plus C1 multiplied by x plus C2. Okay. Next natin na gagawin is we will find our boundary condition at each side. Boundary condition at the left support, and we should solve for the C2, and the boundary condition at the right support and solve for C1. Okay. So let's boundary condition. So x will be equals to 0. At x is equals to 0, and y is equals to 0. So here's our boundary condition. So change natin to ng 0. 0, 0, 0, cancel, 0, and 0, 0, 0. So C2 will be 0. Okay? Or C2 will be equals to 0. So next, the boundary condition at the right support and solve for C1. We need to solve on C1. So at x, ang x natin will be equals to 10. Ano ba? 10. Yan. Ito. X natin will be equal to 10. 10. X is 10. Y is 0. Yan. Okay. Substitute into So, ito ang equation number 2 natin. Tapos ito pala ang ating equation number 1. So, 50.5 multiplied by 10 cube minus 4.167 multiplied by 10 minus 5 4 plus 4.167 copy 10 minus 5 raised to the power of 4 plus 56.167 10 minus 10 raised to the power of 3. Yan. So, solve natin. Plus C1 pala. Tignan natin ito. Lagi natin nalilimutan. Plus C1 multiplied by 10 plus C2 which is 0. So, our C1 is solve natin. 50.5 multiplied by 10 raised to the power of 3. Mali. Minus 4.167 multiplied by 10 minus 5 raised to the power of 4 copy plus 4.167 10 minus 5 ulit raised to the power of 4 plus 56.167 multiplied by 10 minus 10 cube plus C1 multiplied by 10 plus 0. Once we've solved, so our C1 will be negative 5,000 050 5,050. C1 so C2 natin 0. Yan. Next. So, magsasabi sa ano? Calculate the value of the EI theta at the right support of the overhang beam. So, we would need to calculate our EI theta. Okay? So, next. EI theta. So, this is span per feet pala. Hindi, okay na pala siya. So, ayan na ang boundary condition ng EI theta, which is 5,050. Ayun.
Let's try to solve one problem. The given problem is as shown, that is, the simply supported beam supports a concentrated load of 80 kN located 2 meters and 30 kN located 7 meters from the left support. Determine the maximum deflection of the beam. So our required is the maximum deflection of the beam. Then, the next step is to solve for the reactions at the left and the right support. So, meron tayong pin and a roller. So, for pin, we have two reactions. That is AY and AX. For the roller, we have vertical reaction DY. Now, let's solve first the AY, or the left support. So for AY, to get the reactions, kailangan natin mag-moment kay D. So, mag-moment tayo kay D. So for AY, ang ikot ni AY papunta kay D or sa moment, that is clockwise, so positive, then the distance is 10. For the loading, that is 80 kilonewton, dahil pababa yung arrow, and yung ikot niya papunta sa D, pag nag-moment siya, that is counterclockwise, so it's negative. 80 times the distance 8. Then again, the loading, negative 30. The distance 3 is equals to 0. So for the answer is 73 kilonewton. So nasolve na natin yung AY. Then, now we will solve for the DY. For DY, to solve the reactions, magmo-moment tayo kay A. Since the DY has a vertical reaction pataas, and magmo-moment siya kay A, it is counterclockwise, so negative. Negative dy times 10 plus, it's positive since the arrow for the 30 kilonewton is pababa and papunta siya kay A, that is clockwise. So 30 times 7 plus 80 times 2 is equals to 0. Our dy is 37 kilonewton. Now, nasolve na natin ang ating AY and DY. AY is 23. DY is 37. So after getting the reactions, let's now get the section from the left support going to the right just before T, dito tayo magko-cross. So after natin mag-cross, this is now our section from this to this. Then we will solve for the FBT of segment CD. So for the FBD, magmo-moment tayo here. So it is labeled as MCD. So now this is our section with their respective distances ng mga loads. We have X minus 2 for the 80 kilonewton, and X minus 7 for the 30 kilonewton. After the FBD for segment CD, now let's solve for the moment at segment CD. Based sa ating section, magmo-moment tayo papunta sa right. So for the value of AY, that is 73, with a distance of X, it is positive since yung arrow ng AY is pataas, and papunta siya sa right, so it is clockwise. Then negative 80 with a distance of X minus 2. So yung 80 naman, it is negative since papaba yung arrow papunta sa right, so it is counterclockwise. Then negative 30 X minus 7. So nasolve na natin yung moment, then gagamitin natin ito as a working equation sa next step. So for the next step, i-rewrite lang natin to, then papalitan natin yung mga parentheses into brackets. Now, for the first integral, mag-add tayo ng 1 sa mga exponent. Since x is constant and meron na siyang exponent na 1, mag-add tayo ng another 1. So, magiging squared to. So, ikakopy lang natin, 73 plus 1 sa exponent, x squared over 2. So, nakuha natin yung 2 from the exponent. The negative 80 x minus 2 squared over 2 minus 30 x minus 7 squared over 2 plus c1. So, sa every first integral, lagi tayong mag-a-add ng c1 at the end. Next is the second integral. So, for the second integral, mag-add tayo ng another 1 for the exponent. So, magiging 3 siya. Then, for 73, 80, 30, i-divide natin siya sa 2. (73) divide 2, that is 36.5 x cubed over 3. 80 divide 2, that is 40. Copy. Cube over 3. 30 divide 2, that is 15. Cube over 3 plus c1. Then mag-add tayo ng constant x plus c2. So for the second integral naman, mag-add tayo lagi ng x kay c1 plus c2. Now, let's move on sa boundary conditions. Let's start with the left support and solve for the c2. Since it is at left support, x is equals to 0. So, i-rewrite lang natin itong second integral equations. Then, isa-substitute natin lahat ng x into 0. When x is equals to 0, deflection is equals to y is equals to 0. So, sabi ko nga, i-rewrite natin lahat. 36.5, then substitute lahat ng x into 0. 0 cubed over 3 minus 40, 0 minus 2, minus 15, 0 minus 7, plus c1, x is 0, plus c2. Since c2 yung nahanap natin, let's now solve. So, c2, the answer is 0. Next, for the boundary condition at right support, and solve for c1. Dahil nga sa right support siya, the x is 10. So, when x is 10, is equals to y is equals to 0. Rewrite again the second integral equation. 36.5. Substitute lahat ng x into 10 since x is equals to 10. So, 10 cubed over 3 minus 40, 10 minus 2 cubed over 3 minus 15, 10 minus 7 cubed over 3 plus C1, 10, and C2, our answer is 0. So now let's solve using the calculator. So the answer is negative 520.50. So nasolve na natin yung C2 and C1. Just to remind you that this is the first equation and the second equation. After natin makuha yung C1 and C2, now let's solve the equation of slope. So the equation of slope is equals to the first integral. So i-rewrite lang natin yung equation 1, then substitute the C1. Copy, 73. Then, i-move na natin yung 2 here. So, magiging 73 over 2 x squared minus 80 squared, 2 rather, minus 30 over 2 x minus 7 squared, then substitute the C1, negative 520.50. Now let's move on sa equation of deflection. So the equation of deflection is equals sa second equation or the second integral. So ikakopy lang natin siya, i-rewrite lang natin, then substitute the C1 and the C2. Same format lang here sa equation of slope. (36.5) over 3 x cubed minus 40 over 3 x minus 2 cubed minus 15 over 3 x minus 7 cubed minus 520.50 x. Since yung answer natin sa C2 is 0, kahit hindi na natin siya isulat. So, ito na yung equation of the slope and the equation of deflection. Next, isusolve naman natin yung location of the maximum deflection or the x. So, for here, gagamitin natin yung equation of the slope. Just rewrite 73 over 2 Then, ika-cancel out natin ito, and ito. So, ang matitira is ito, and the 520 minus 50. So, ito yung isosolve natin para makuha yung location of the maximum deflection. So, sa calculator, yung x, ito yung magiging alpha natin. So, now let's calculate. So, x is equals to negative 3.78. So, ito yung location of the maximum deflection. Now, we already have this answer. Gagamitin natin siya para makuha naman yung maximum deflection. I-rewrite lang din natin itong location of the maximum deflection na solution na ginamit natin. Then, isa-substitute natin yung x base na nakuha natin. That is negative 3.78. Let's write the equation of deflection. So, dito tayo magbe-base. 36.5 over 3. Then, yung x here, isa-substitute natin ito. So, magiging negative 3.78 cube. Since naka-cancel out na to, hindi na natin isusulat to for the maximum deflection. So, diretso na agad tayo sa ating C1 minus 520.50. Then, yung x natin dito, substitute natin, negative 3.78. Let's calculate. So, the answer is 1,310.37.